This symposium is called the emerging concept of the protein clearance, right? Because we understand that in an AD kind of situation, we have the production problem as well as the clearance problem. So this concept is we're trying to put together is that in the brain we have this clearance mechanism, particularly utilizing the vasculature. So there's two routes of clearance. One is they call the perivascular flow. There's a flow that is next to the vasculature, but it basically carries things around the vasculature and eventually goes to the lymphatic system. And then there's also this transvascular, basically, as I talked earlier, so it basically it depends on the receptors. So if you have the receptor on the, let's say, vasculature, you'll capture those ligands, particularly, let's say, amyloid beta, and take the amyloid beta, across the blood-brain barrier. So this is called transvascular clearance. So there's two different pathways plays different roles. And this basically this concept, what I try to put it together is this is very important to maintain the homeostasis of those amyloid in the brain. And during let's say the MAD pathogenesis, we found there's different level of sort of, I would say, impairment in both pathways. And Roxana showed that when there's perivascular clearance problems, and the amyloid beta basically stuck in the perivascular space. And what we show is that when you have reduction in the PICOM and ORP, there's less transvascular and also stuck in the brain. So these two pathways are both important. We don't know what's the exact contribution, but both pathways seem very important. Now the next goal is to understand better is that, okay, let's say in a different stage, because AD, we have different stages. We don't know what's the contribution of two different pathways at different stage. And so the goal for the next stage for us is to understand better. Let's say maybe one of the pathways will contribute differently at different stages. And for example, as we discussed after the meeting, is that maybe the transcytosis probably occur earlier because you have the receptor. Now, because this receptor is an active transporter, so they work very nicely like the train, right? But once you have the train stop, you have to rely on the flow. So when both is impaired, then everything's stuck in the brain and causing this sort of pathogenesis. But currently we are relying on very heavily in animal models. And so we're hoping that we can generate new sort of animal models to show that at different level, different sort of, I would say, stages, to show there's difference in terms of these pathways that we can target. So this is, I would say there's a few more years for us to really work on and to show that in different animal models that occur, that things that occur sort of differently. And eventually we can sort of utilize the animal model to explain what's happening in the human. And so, and as also, there's a different talk in the symposium. It mentioned that besides of the vascular clearance, there's also innate immune cells in the brain called microglia. They also take up those garbage and clear. So there's a very complex issue in the brain that really clears out those toxic proteins. And so right now, I think people has appreciated our findings. They understand it's a really big issues, right? But the focus or the emphasis is not enough. So we're trying to advertise that this is a big problem there. It's as same as important as the production. Because a lot of people has been focusing on the production, right? Including the antibodies, monoclonal antibodies targeting amyloid beta, as well as inhibitors to the gamma secretase, beta secretase. Those are the production side. We are understanding the clearance side. So there's a balance between the production and the clearance. Hopefully that if we target both, then we can have a better sort of drugs for the AD. Yeah.